Excellent. So I am Govind Rangaswamy, former founder and CEO of Pranix that was acquired by Commvault, and now it's Cloud Rewind. And I think I have about 30 minutes or so to go through. So what I had in mind is to go through a quick overview of what we can do with the Cloud Rewind product within Commvault portfolio, and give you a quick demo if you have time to go through a comprehensive view of what Cloud Rewind and where it helps. And of course, there will be questions in between. I'm happy to answer those as well. So when we look at cloud application, what you see on the right-hand side looks to be like an electronic circuit board. This is not an electronic circuit board. This is a real-world cloud application environment on an AWS customer region. And this application is running across 3 different availability zones. It has multiple RDSs in the backend. It has about 146 application load balances and similar number in terms of network load balances, EFS system, and you name it, all the networking complexity. So when you think about a traditional application versus cloud application, it's night and day. That's the point that we kind of explain, and we highlight the fact that cloud applications from the get-go are dynamic and very, very distributed in nature. Even if those applications were lifted and shifted, similar to this particular customer's environment, this is part of financial services, which is doing about $16 to $20 billion in mortgage payments every quarter, right? And the second thing that we notice is that these application environments are changing rapidly, right? They are not sitting idle. These applications environments are being driven, let's say, from the latest buzzwords, like AI-driven DevOps pipelines. They are literally now being driven by Copilot created code, which means that they are changing the cloud environment faster and faster and sooner and sooner. And those environments are also going through several other ways, through Cloud Console or through third-party tools. So at the end of the day, the changes to these environments are much higher, on an average roughly about 50 times a day in terms of the number of changes that go through these environments. So the question becomes, how resilient are your cloud applications? The third thing that we notice is that the scale of these environments are also much higher, right? What used to be a simple data center application, if it was lifted and shifted or even got created directly on the cloud environment, over a period of time, because you can logically create cloud accounts or now separate VPCs, you'll end up seeing a lot more services running for your applications, even if you took logical separation of dev test versus performance test versus your production applications. There are a lot more services to manage. So the scale becomes another huge problem. So most senior leaders do not even know what they're running. That's why they're running into cost problems. But from a resiliency perspective, you are not really seeing or discovering these environments. How can you really protect, or how can you really bring resiliency to this environment? Now, the common solution that's prevalent in the industry is that if you want to have disaster recovery, or if you want to have a mechanism to come back from, let's say, a regional failure or a zonal failure or some kind of a misconfiguration issue, either by the cloud provider, right? Sometimes the account itself gets deleted, or typical human error might get rid of some of the back-end infrastructure for those applications that are running for some time. So your SLA gets affected. But the solution, the best practice, is that you have an idle environment, or at least some of those application infrastructure created and kept idle. Now, a few problems with that model, the traditional recovery environment. The problems are, first of all, you end up managing a lot more services, a lot more infrastructure, and a lot more resources just because you have the idle environment. Second of all, if those idle environments are kept in there, initially created, but your production is changing so many times per day, your idle environment, your recovery environment is drifting away from the production, right? So kind of that idle environment is useless. Third, the most important thing is that if your production environment gets attacked, if the idle environment is kind of connected to it, that environment will also be attacked. So in the end, you have not only completely wasted your budget on an idle environment, second of all, you also wasted resources, meaning human resources, to manage that. And third, you're not really benefiting out of it. So the solution could be that, protect all of these resources properly, meaning that not only protect the data of those applications, it could be all your EC2 instances or Azure resources, and behind it, you'll have to protect all the disks and all the RDS databases and so on. Not only that, but also protect your configurations. Because when you want to recreate or rebuild after a failure, you got to have all those configurations and the dependencies mainly properly protected as well. So what we are saying here is that change your protection approach so that you can recover your applications fully, not just the data. We give a lot of data resiliency products, right? We have seen Clumio, we have seen our Commvault solution that has been around for decades. So we know how to protect the data. But the model of protecting the data is, I need to go beyond just protecting the data to protecting the configurations and the dependencies together as a whole, roughly. That way, at the time of recovery, you don't have to really think about several runbooks. Typically when you think about a security team, after a security incident, they will have a runbook. An application team will have a separate runbook, or your application architecture team would have a separate runbook. Your backup and recovery team would end up having separate runbooks. Instead, you can combine all of that. You can simplify and have one. And typically, these advanced cloud users tend to create their own frameworks, starting from the backup product. Backup your data first, and then you can build some kind of a backup service on top of it. Have a replication for your data to go from one region to another region. And then you need to have some kind of a configuration management database, and then infrastructure as code. And on top of that, you put an SLA so that you can really derive an SLA for your application as a whole. And while you do that, create that framework or a product by yourself, do it yourself mechanism, your hyperscaler is changing the services underneath. So it becomes really, really complex. Instead, what we are saying is that you could use Cloud Rewind. Because Cloud Rewind gives you a cloud time machine. And that cloud time machine has two different vaults. One vault is for all the configurations, all your EC2 instant configurations, the dependencies between the EC2 or Azure infrastructure services, PaaS services, and so on. So pretty much all those configurations and the dependencies are continuously discovered and collected from an application-centric perspective. Because these environments are changing, faster and faster. So the continuous discovery process and the dependency management takes care of it. Second, what Cloud Rewind does is it also orchestrates the data, meaning it takes your application data from one region and replicates to another region. And we employ directly the cloud native mechanism. We are using AWS backup service or Azure backup service. In addition to that, we pretty much replicate the data. So imagine you have the backup, but we also replicate, so you don't have to buy a replication product. You can replicate to another region. You can replicate to another account. And it's also incremental. So we give you a choice in terms of data management. You've seen now you have options to backup and keep it in an air gap copy, or backup large amount of data, or backup right there on the particular account and across to another account. So multiple levels of resilience. Third, when you want to recover, you can pretty much offload that work to, in fact, rebuild the entire application environment. And that automatically is done by Cloud Rewind using recovery Escort. So we have introduced in the market, in the industry rather, two important concepts. One is this cloud time machine for your cloud environment. Second is recovery Escort. What the recovery Escort mechanism does is it automatically combines all your several runbooks into a single infrastructure as code-based runbook, and is completely automatically written for you based on the location or the region that you want to recover. And it knows the dependencies, so you don't have to really understand that the dependencies between your infrastructure services, your PaaS services, your Lambda services. Rather, you simply offload all of that. So you can go and rebuild or recover by going back in the cloud time machine across to another zone, across to another region, across to another account, depending on your use case. So you don't have to worry about the application centricity. And people tend to kind of use Terraform scripts, but the approach of Terraform script is that, just like what we do, we use Terraform internally. You can see on the left-hand side, it's a busy slide, but the point is that you don't have to really use the Terraform mechanism for resiliency. You continue to use that. We co-op very nicely with Terraform. You continue to use that for your production. But when it comes to resiliency, that combines disaster recovery and cyber recovery, along with managing drift, can be done in a single product across multiple cloud environments. So it is application aware, so can really go after your SLA for RTO and RTO. Right? And that's what customers like this one, financial services, it's not a huge environment, it's about 3.985 petabytes. What they used to do for a single recovery test used to take 72 hours over a weekend with hundreds of people in the call, because they cannot do it anywhere in between. In the middle of the week, they can't do it. And recovery tests need to be done often. And now they are able to do that recovery test in about 32 minutes. Because it's all a single click for every one of the tiers. So 5 tiers of applications. And the largest tier is basically pulling the data out of the RDS. And they are using one of the largest Oracle RDS instances on this region. And it can all be done. It completes in about 32 minutes. And that way, they are encouraged to do more and more. And now, if you think about a typical enterprise, which has about 2.5 to 3 different cloud environments, you don't have to have PhDs across multiple clouds for resiliency. You can get all of that done with a single platform. It's almost like the middle layer for your resiliency on top of your cloud accounts. That way you can offload a lot of that resiliency testing, recovery for individual or partial applications, or even achieving resiliency across to another zone or another region. Because sometimes what happens is that when you have done under the precept of digital transformation, lift and shift applications end up in only one zone of a particular region, because that's a data center. And they may not have even done anything with respect to testing that application for recovery purposes in another zone or another region. That can all be offloaded to a platform like Cloud Rewind. And that's a typical approach. And this is what has happened with one of the e-discovery firms when they had an encryption attack, literally. And that took down 18 Azure subscriptions. They were paying for all the resources but they could not use, meaning their customers could not use any of that because the customer could not get into the environment. The company could not get into the environment because all of the resources have been completely locked up, including their AD. Cloud Rewind was able to rebuild everything, isolated from that infected environment. That infected environment was given to the insurance company to go and do forensics so that they can prevent future such incidents. Whereas Cloud Rebuild was able to rebuild everything in another environment so that they can continue to operate from that environment. So that's the level of capability that we bring in. Let me stop here and see if there are questions before jumping on to the demo itself.
I would have a couple of questions for you. So first question is like, speaking of the drift, configuration drifts and stuff like that. So, most of clients I'm working with, they're using infrastructure as a code to manage their cloud environment. So how do you manage to keep these two in sync? So, I'm managing my environment with the infrastructure as a code, and I have the Cloud Rewind, and there's the event, and I need to recover exactly what was in the moment before the attack. And I want to avoid it. I will need to maintain like this repo with the code to manage my environment. And I need to manage my Cloud Rewind to keep it up to date so there's no drift between those two. Is there any sort of a integration, or how do you ensure this?
We have a loose integration mechanism. So first of all, in that situation, the number one thing that the customer would want to have is their applications back, right? And they shouldn't be scrambling across multiple repositories of the infrastructure as code. That is one of the biggest problems. Is why people do not do the recovery testing often, even in this infrastructure as code world, right? They don't do it because it's too complex. One layer taking care of the networking, another layer for, let's say, PaaS services, another layer for application services. Within application layer, there may be multiple repositories. So they don't even talk to each other. That is the type of the runbook that I explained. What Cloud Rewind would do that is that it directly goes to the infrastructure. It doesn't go to the repositories of the customers, infrastructure as code repositories. Cloud Rewind uses the cloud native API to query all the configurations and the dependencies directly from the infrastructure itself, because infrastructure at that point is the single source of truth, not your repository. So we directly go and collect all that configuration data and the dependencies data along with the data, application data.
So I would tend to disagree on what you said, because if there is the attack already ongoing, my source of truth should be my repo, right? Like that shouldn't be what is going on in my cloud environment, because what if already, I'm being attacked and you suddenly are pulling the wrong information from my cloud environment? So then when you will be recovering, you're basically recovering with already a compromised environment.
That is why the cloud time machine helps, right? You can go back in time to a cleaner copy.
Okay.
And that's the difference in terms of what Cloud Rewind does, is that you can go back at the moment of you're running applications. When you run your application environment, you're running across multiple instances, for example, right? And you're using multiple load balancers. I mean, these are all separate code repos. Your Lambdas are using something else, and your VPC is being deployed across multiple regions or even multiple availability zones using a different repo. So all of that is already being deployed. Now, when Cloud Rewind comes in, it automatically detects all of that. We are able to, after getting the permissions to discover read-only, we can go in and get for RDS, even if it's a single RDS for a simple parameter group, you have 589 parameters. So you could save the data, you can back up the data, but if you don't have your RDS along with all the parameter groups as it was before the attack, there's no point in having the data because your RDS is not going to run. So you not only have to have this RDS as it was before the attack. It could be an hour ago, it could be 4 hours ago, or even yesterday. Got to have the same RDS with the same parameter groups, along with the rest of the configurations, right? So that I can reproduce that application as I had shown is one of the tiers of the application. And even in those incidents, if the region is down for whatever failure mode was for AWS, you should be able to rebuild across to another region. And what if your production comes back? I should not be interfering with your production. So I could pretty much do it across to another account, completely isolated, or within the same account in a different VPC. So for that, I can go to Cloud Rewind and do a cloud connection. And when I do a connection, I am basically doing a handshake between Cloud Rewind and the customer environment, right? And I can simply add a cloud connection for my AWS, put in the region that you want to go. And if I'm running in Virginia region, simply select that. I can go to Oregon, or I can go to Mumbai, add as operational regions. That's simple. Now imagine before the hyperscalers, you'll have to have data centers created, built with all the service and so on. None of that. So Cloud Rewind pretty much takes advantage of all the on-demand nature of the hyperscalers. So we include that. Yeah.
Right. Sorry, I will have a second question. And Govind, can we go back into the slide, please? And I'm going to ask the same question like in the previous session. So you mentioned the Kubernetes. So how deep you can go into the Kubernetes in terms of the recovery?
It is including the configuration maps. So all the Kubernetes EKS or AKS and so on, we can go into the Kubernetes cluster configuration maps.
Okay, cool.
So when you're bringing up a cloud application, there are certain sequences that might be required in order to bring up things earlier than later. Is that something you guys provide automatically, or how do you detect that with your continuous learning system?
What we do is that when we discover, we even know when a particular EBS volume was attached to an EC2 instance. Because we have been at it, right? So based on that information, we use several mechanisms for that. One is, knowing the data at which point the EBS volume was attached to an EC2 instance. And also we give you segregation across multiple assemblies. The concept that we introduced in the market is something called a cloud assembly. An assembly is nothing but a set of dependent resources for that particular application. You could even create a cloud assembly for a bunch of RDS systems. And this is what exactly happens with the financial services. They keep that as a single tier, and your RDS need to come up first. Or even within the same application environment, if the EC2 instance happened to have an EBS volume that was attached yesterday versus today, we would know that. So we would bring up that old one first. And that is all done automatically based on your current infrastructure or whatever the time that infrastructure was captured. So you could go back in time and an hour ago, or even a month ago, right? Yesterday, you can go back in time. That gives that time series information along with the tiering. Right? And sometimes you may be right in terms of very complex application, you will have to tier separately. And for that, we give you a kind of a super assembly through the API. So you could combine let's say this particular application environment needs to come up first, and you can call that using your API mechanism second. So we will give you that option. Third, we give you a mechanism for you to attach additional intelligence for your application here at the post and pre-webhook model. So you could program whatever the way you want in terms of modifying that mechanism before the recovery happens, or before a rebuild happens, or after the rebuild happens. So we have several mechanisms around that particular cloud assembly, which itself is a complex piece.
So the other question I have is, where is the data actually backed up to? Is it sitting in Clumio Secure Vault? Is it sitting someplace else? I mean, is it within the region? Is it outside the region? Is customers actually able to control where that data resides?
Absolutely. This is where you simply put a single policy. I mentioned this particular thing about capturing your configurations and the data and the dependencies roughly together. Because if you have a database coming up as of yesterday, and if you have a load balancer as of today, they will not talk to each other, or they may not talk to each other. So even if you brought up your data securely through any of the vaults, it's of no use because your application is not running. So that is the first and foremost. So once you have that view, you put a policy for the entire application. And that policy could be something like this, capture the entire configuration and the data every hour, and put the retain number of copies in the same region, or ship the copies to another region, or put the copies across to another account. That is all single policy. One policy taking care of your backup as well as replication and so on. There was one other thing that I wanted to answer. Where is that application data? The application data, based on your policies, is well within your own cloud account or in another region of your cloud account or another account that you have dedicated for that particular application, or combination of all of this. So you have multiple mechanisms with a single policy approach. That way you're not working hard when it comes to that distributed and dynamic cloud application. You make it that simple. It's very similar to what you saw in Clumio set and forget model.
Could you use a solution to, let's say, migrate from AWS to Azure, or is that out of the realm of this environment?
People always out of the possibility, right? We don't recommend that. It's not about application. It's not even the data. It's about the dependency. It's about the service. When you go to...
all those things are part of the picture that are required to be migrated when you go from one cloud vendor to another. The data, the application, the metadata, all the structures, all the linkages.
Everything exists, yes. But the issue here is that they are not compatible services.
Yeah. I agree.
That's why we don't recommend. But, if you are running really tightly controlled architecture, let's say on Kubernetes, we do offer that mechanism. If it is completely well within that Kubernetes system, because it is running completely on containers on Linux-based images, potentially you could go from AKS to EKS or EKS to GKE.
And the data backed up, is that compressed and things of that nature, or is that just pretty much an image of the EBS volume or the RDS or whatever it is?
Correct. We don't compress the dedupe. That is what our data management products do. So we give you the option in the market, right? We give you the capability to achieve resilience, and in Cloud Rewind, people typically go for 3 to 5 copies. Otherwise, it becomes expensive. And if the customer sees that it's expensive, they can offload that copy over to our AGP, air gap copy, which is compressed and dedupe. Or if the S3 buckets are really, really large and numerous, billions of objects, we give you the option to offload that to Clumio. So we give you all of those facilities. That way, you get to choose the level of resiliency that you want from an application perspective.
As far as the cyber threat detection, assessment, and all that stuff that Commvault, other solutions provide, is that also integrated with Cloud Rewind?
It's integrated through our extension mechanism, right? We don't directly integrate because every customer changes and more integration is coming. And we got acquired about 12 months ago. So
Okay.
integration is done. And then
Okay.
all of this will be within a single platform, giving you multiple levels of that resiliency, right? But at the end of the day, it comes down to the capability to bring up your entire application. And for that, all you have to do is to go back in time, click a button, and then say, I want to go to cross region or cross account, and I want to rebuild it, right? Tech day rebuild. And all I have to do is to select that. Let me put this one up there and hit recovery, and then say recover. And if you're doing tests, simply turn it on like an iPhone toggle and hit that recovery. When you do that, Cloud Rewind knows as of an hour ago, and it could as well go back to yesterday or last month and so on. It has all that information about your route table, the security groups, the load balancer group, and target groups. Nobody knows all of this because the cloud provider has been changing, right? And you could do that not only here, but across, let's say, if you're running on Azure, you do the same thing. You can go back and then hit the button and then do the same thing for cross subscription on Azure. Or you can go to your Google and pretty much you do the same thing here as well. And in all of these clouds, the entire architecture of the cloud is different. And you don't have to really put in people to manage all of that because it's all done for you. Extreme level of automation, because at the end of the day, what people are looking for is a mechanism so that I can bring back the entire tech day rebuild with a click of a button. And that's the code that automatically gets written because it's not huge. It's about 1,500. And this is bringing up not only the application components and the dependencies, but also the data so that your entire application is coming up, right? This is the tech day rebuild deployment happening across to another region. Your load balancers, your VPCs, you don't have to even rebuild you don't have to keep the VPC running because the VPC might be changing all the time. And you get it done really, really quick because the platform automatically takes care of. So you can see all of these are already built and it's running in the California region here. Right? Tech day rebuild is happening. The resources are coming up in California while the production is running here in the Virginia region. So that's the overall idea here.
Thanks, Govind. So, first of all, thanks, Govind, Akshay, and Michael. Just in wrap up, I think I want to touch on a few things that you saw over the course of the day. One of the reasons I'm so excited that we now have, Clumio and Cloud Rewind as part of the Commvault portfolio and platform is even before we acquired these capabilities, some of the things you heard Michael Fasulo go through around helping our customers not only remain resilient, but especially in kind of their complex multi-cloud and hybrid cloud worlds is we were already managing, exabytes of data in the cloud. Beyond the obvious kind of integration points that we're starting to do with Clumio and Cloud Rewind, some of the stuff that we're taking into the platform goes beyond just kind of the straightforward integrations. There are things that you can do in the cloud when kind of it's all code and configuration, as you're suggesting, that's either really hard to do or in some cases just impossible to do in a traditionally packaged world. So some of the things that we were learning from these teams is how can we apply some of these mechanics that go well beyond integration and bring that to some of the other facets of our platform. As just one example, some of the stuff Govind was talking through, I think it is a great example of how Cloud Rewind goes way beyond just data recovery and really helps organizations start to recover aspects of their infrastructure and kind of full cloud stacks in the examples he provided. And so expect to start to see some of those ideas and mechanisms that get applied holistically kind of throughout the platform, that aren't just applied kind of in these sorts of cloud contexts in addition to some of the integration work that we're continuing to do across both of those products. So thanks not only for your time, but also your engagement. It was great to get a chance to hear all the questions and tackle many of them. We didn't get a chance to actually dive deep and do a demonstration of the Clumio stuff, so we'll follow up and we could do that, one of those for those who are interested.